guys, so this video is for lesson 4. So with the last video, lesson 3, I mentioned that we were staying in the first quadrant. We're going to start to travel outside the first quadrant now. So if you remember, first quadrant is the top right, and then we go counterclockwise, I said. So second quadrant would be top left, third quadrant bottom left, and fourth quadrant bottom right. So here it says, it is important to be able to determine the sign, positive or negative, for each of the 3 basic trig functions for any angle whose terminal ray lies in a given quadrant. The next exercise illustrates this process. So exercise 1. For each quadrant below, determine if the sine, cosine, and tangent of an angle whose terminal ray falls in the quadrant is positive or negative. Hint, think about the coordinates of the point that lies on the unit circle. So this circle here is a unit circle, which is why its radius is 1. So remember, a unit circle means that every point xy is equal to cosine, comma sine. So we're going to use that to help us. So quadrant 1, if we're a point sitting in quadrant 1, think about your coordinates x and y. We're trying to figure out if we are positive or negative. So in the first quadrant, to get there, you would have to travel to the right and then travel up. So traveling to the right means that your x-axis is positive, and traveling up means that your y-axis, you are also on the positive side. So no matter where this point happens to be, both the x and the y will be a positive number. X, remember, is cosine, so that means in the first quadrant, cosine is positive. Sine is the y, and since y is positive, sine, we say, is positive in the first quadrant. Now, tangent is not one of the points, one of the coordinates, but we should remember one of our properties. Tangent is equal to sine divided by cosine. So if I am in the first quadrant, sine divided by cosine, both sine and cosine are positive numbers. So if you take a positive and divide it by a positive, your final overall answer will also be positive. So in the first quadrant, we say that all of the functions are positive. Now, if I travel outside of the first quadrant, so if I am now a point sitting in the second quadrant, what does that do with my positives and negatives? So to get to the second quadrant, you would travel left. So we're now on the negative side of the x-axis. So your y is going to be a negative number. The x. The y, if I go up, is going to be a positive number because you are on the positive side of the x-axis. So x again is cosine because we went to the left. X is negative, which means cosine is negative in the second quadrant. We traveled up on the positive side of the y-axis, and y is sine, so that means sine is positive. And now tangent, again, it's sine divided by cosine. So if I take a positive number and divide it by a negative number, you will have a negative answer. So that means in the second quadrant, tangent is negative. Okay, third quadrant. If I'm a point sitting in the third quadrant, here's my x and y. Again, I have to travel to the left of the x-axis to get to the third quadrant. So if I'm traveling to the left, it means I'm on the negative side of the x-axis. Then I have to travel down on the y-axis to get to the third quadrant. And if you're going down, we should know that our y-axis is negative. So that means in the third quadrant, if y is negative, that's our sine. So that means sine is negative. Cosine is the x. The x we said was negative, so cosine is negative. And tangent, a negative divided by a negative, would get me a positive number. So tangent is positive. Last quadrant, quadrant 4. Here's my point, xy, sitting in the fourth quadrant. To get there, I have to travel to the right on the x-axis, and that is the positive side of the x-axis. I then have to travel down on the y-axis. That's the negative side of the y-axis. So for sine, sine is the y again. That was negative. Cosine, that was the x. That was positive. Tangent, sine divided by cosine, a negative divided by a positive, is a negative number. So tangent is negative. So this chart here sums up the signs of all of your trig functions, who's positive in which quadrants and who is negative in which quadrants. It is important to notice that in every quadrant, after the first one, only one trig value is positive, and each trig function is positive in 2 and negative in 2. One way that we can use to help sum it up, if we draw our x and y axis, it makes a plus sign. So what I'm about to give you tells us who is positive in each quadrant. So first quadrant up in the top right, I put an A there. Because if we look at the first quadrant in that table, all of them were positive. So A stands for all. In the second quadrant, if we take a look here at the chart that we made, the only positive I see there was sine. So I put an S there for sine. That means that when I look at this chart and I see an S in that quadrant, that is telling me that sine is the only function that is positive in the second quadrant. If I'm any other function and I fall into that second quadrant, by default, I would have to be negative then. Third quadrant, my positive was tangent, so I put a T there for tangent. And fourth quadrant, the only positive we see here is cosine, so I put an C there for cosine. So again, this tells us who is positive in each quadrant. So we remember it as just ASTC, little acronym that can help. All students take classes. All students take chem, traveling around. And again, this tells us who is positive in each quadrant. So if I say I'm in the third quadrant, what is cosine sine in the third quadrant? Because there is a T in the third quadrant, that's telling me that only tangent is positive there. So if I am cosine and I'm sitting there, by default, I would have to be negative. So we're going to see how to use this in the next few problems. Exercise 2. Using the Pythagorean identity, cosine squared plus sine squared equals 1. This is what we came up with in lesson 3. Find the value of sine theta to the nearest hundredth if cosine theta is 0.7 and theta is in quadrant 4. So dealing with the quadrant, I'm going to save that as my last step for every problem. We're going to start this the same way we did at the end of lesson 3. Cosine is 0.7. So I'm going to plug that into my Pythagorean identity. Cosine is 0.7. Cosine was being squared in the identity, so 0.7 is going to be squared. Plus sine squared, that is what we're going to be solving for, equals 1. So 0.7 squared, you can do it on your calculator. You should get 0.49. Subtract it to the other side. So we should get sine squared equals 0.51. To get rid of the squared, we take the square root of both sides. So we have that sine is equal, you're going to get a long decimal here. It's telling us to round to the nearest hundredth. So we should get 0.71. When you are doing trig, your last step, I want you, for every trig problem we do, I want your last step to be to think about ASTC. Again, this is telling us who is positive in each quadrant. All of trig is going to start telling you which quadrant you're in. So right now we are in quadrant 4. So here's quadrant 4. There is a C there. Remember, this is telling us who is positive in each quadrant. C stands for cosine, which tells me only cosine is positive in the 4th quadrant. So right now, if we found sine and we're in the 4th quadrant, sine has to be negative. Only cosine is positive in the 4th quadrant. So my sine, where I got this 0.71, I need to make it a negative 0.71 in order to satisfy my criteria for being in the 4th quadrant. And again, the reason it's negative comes back to up here, 4th quadrant, sine is the y value. And if I'm in the 4th quadrant, I have to be on the negative side of the y-axis. So since y is negative, sine has to be negative. So that is why we have this negative 0.71. So now next part, use this answer to find the value of tangent theta to the nearest thousandth. Tangent theta, remember, is sine divided by cosine. So we're going to take our answers here. Sine is negative 0.71 divided by cosine. Cosine, the original cosine was 0.7. So dividing and rounding to the nearest thousandth, you should get negative 1.014. Now again, last step I want you to do is just double check your ASTC. Double check your sign that you are correct. We're still in the 4th quadrant, have not moved. So 4th quadrant again has a C there, only cosine is positive. So if I am tangent right now, I have to be negative, which is good because that's what our answer came out to. But this is still going to be your final step for all the problems. You can do them all normal, but at the end, just make sure you're double checking this ASTC that you have the correct sign with your function. All right, exercise 3. For an angle drawn in standard position, it is known that its cosine is negative and its tangent is positive. The terminal ray of this angle must terminate in which quadrant? So all I'm trying to do is figure out which quadrant I am in that I satisfy these two conditions. 1, that cosine is negative, and 2, that tangent is positive. So we're going to look at our ASTC, which again, remember, tells you who is positive in each quadrant. So my first criteria is that cosine is negative. Well, which quadrants is cosine negative in? Remember, I said that every function is positive in 2 and negative in 2. A stands for all. All of them are positive there. So if cosine is negative, I know I'm not in the 1st quadrant. S stands for sine. Only sine is positive in the 2nd quadrant. So that means cosine being negative, that would work there. I could possibly be in the 2nd quadrant if cosine is negative. T stands for tangent. Only tangent is positive in the third quadrant, so cosine being negative would work there. Fourth quadrant, C stands for cosine, which means cosine is positive there. I want cosine to be negative, so fourth quadrant does not work for that first criteria. Second piece of information, though, was that tangent is positive. So based on the two quadrants I have left here, quadrants 2 and 3, I want tangent to be positive. Well, this chart tells me who is positive in each. So if I want tangent to be positive, it means I need to be in the quadrant with the T in it. So that is quadrant 3. So I am answer choice 3. Exercise 4. A circle centered at the origin has a radius of 10 units. The terminal side of an angle theta intercepts the circle in quadrant 1 at point C. The y-coordinate of point C is 8. What is the value of sine theta? Now, here's where we start to be a little bit different than how we were doing lesson 3. Big thing is that this is just saying this is a circle. It makes no mention of unit circle. Remember how I said x and y match up with cosine and sine? That, remember, is only true on the unit circle. And since this is not a unit circle, I cannot assume that x is cosine and y is sine. So instead, I'm going to draw a picture for this. So we have a circle centered at the origin, and we know it has a radius of 10 units. The terminal side of an angle theta intercepts the circle in quadrant 1. So terminal side, remember that's just a line that comes out. It's hitting the circle in quadrant 1 at point C. Now remember, every point is an x comma y. So this point C has an x and a y with it. The y-coordinate of this point is 8. So I'm going to fill in an 8 for the y. What is the value of sine? Now, anytime you're looking for a trig function, if you think you don't have enough information, it's not a unit circle. If I'm looking for sine, I can't make it my y. Instead, I'm going to have to go back to the basics of trig. Sine SOHCAHTOA. In order to find sine, I'm going to have to do opposite over hypotenuse. And if I'm talking about an opposite and a hypotenuse, it means I have to be dealing with a right triangle. Now, if you remember from lesson 3, I said when you make your triangles, we're going to always go from the point straight to the x-axis. So here is my right triangle. I'll make it a different color so we can see it. The angle we're going to refer to is always closest to the origin. So I'm going to zoom in on this a little bit and make it a little bit bigger for us. That's going to be our theta. Now, this is my hypotenuse right here. Remember, the hypotenuse of this circle also happens to be the radius. It's connecting us from the center to the outside edge. And we said the radius was 10, which means our hypotenuse is 10. Now, the point that was sitting up here, we know it's the coordinates x, comma, 8. X always talks about a horizontal distance. My x-axis goes left to right, so I'm talking about the side of the triangle that goes left and right. So that side is side x. Y, which is 8, is always talking about a vertical side up and down, just like the y-axis goes up and down. So that vertical side of my triangle is 8. Now, in order to find sine, opposite over hypotenuse. Hypotenuse is the 10. It's across from the right angle. If this is my angle theta down here, opposite would be the 8. So I happen to have all the sides I need here. So sine opposite over hypotenuse, we get 8 over 10. If I needed the missing side, remember Pythagorean theorem would work. And I recommended for all of these, your last step, just double check ASTC. We're in the first quadrant. First quadrant has an A, which means all of them are positive. So sine, we have an answer that's a positive. So we are good with our final answer of 8 over 10. If you want to simplify to 4 over 5, you can, but you don't have to. Okay, question 5. An angle alpha has a terminal ray that falls in the second quadrant. It is known that the x-coordinate of the point where the ray intersects a circle centered at the origin is -12, and the y-coordinate is 5. Find the value of cosine of alpha. Now, another thing to point out again, we're talking about a circle, but not a unit circle. So unfortunately, I cannot use the fact that x is cosine and y is sine. So I'm going to go back to a picture again like I did in the last one. This time, it says that our terminal ray is in the second quadrant. So here's my terminal ray sitting in the second quadrant. And it says that the point where the ray intersects the circle, the x-coordinate is -12, and the y-coordinate is +5. Find the value of cosine. Just like the last problem, I said for these we're going to go back to the basics, SOHCAHTOA. In order to find cosine, we're using alpha here. SOHCAHTOA, we're going to do adjacent over hypotenuse, which means I need a right triangle. Now I said you're going to go from the point, this is our first time doing it in a different quadrant. You're going to take the point and go straight to the x-axis to make a right triangle. So here is our triangle. The angle I said will always be closest to the origin, so that's going to be the one on the bottom. So I will zoom in here for you, make it a little bit bigger without everything else. Here's alpha. Now, remember the x, that's the side of the triangle that's on the x-axis. So x, they said, was -12 for this point. So the x, the horizontal side of my triangle, is -12. That's the bottom. Y is 5. That's the vertical side of my triangle. So the side that goes straight up and down. And this one, unfortunately, they never mentioned a radius, which is our hypotenuse. So unfortunately, we don't know what the hypotenuse is here. If I want to find cosine, though, I need to know what that hypotenuse is. So we are going to have to find the hypotenuse. Finding missing sides of a right triangle, we're going to use the Pythagorean theorem. Oops. A squared plus b squared equals c squared. C, remember, is the hypotenuse, which is what we are looking for. So that's going to be my x, or you can leave it as c. A and b are the other two sides of the triangle, so 5 and -12. When you go to square these, make sure that -12 is in parentheses because you should get a positive 144. Adding it to 25, you get 169. Take the square root. We get that our hypotenuse is 13. So cosine, we know the hypotenuse. Opposite that angle is the 5, which means the adjacent is the negative 12. So cosine of that angle adjacent over hypotenuse is negative 12 over 13. Now, double check it. I said last step for all of these trig problems from now on. ASTC. We are in the second quadrant, they said. Second quadrant has an S, which means only sign is positive. So since I am cosine in the second quadrant, I should be negative, which is good because that's what our answer came out to. If it did not come out negative, I would put the negative into my answer here. All right, last question. It is known that sine of alpha is equal to negative 3 over 5, and cosine of alpha is less than 0. Determine the value of tangent of alpha. Now, tangent, remember, is sine divided by cosine. When I do sine divided by cosine, I know what the sine is. I have negative 3 over 5. But unfortunately, I don't know what cosine is right now, so I'm going to have to find it. All I know is that cosine is less than 0, which means cosine is negative. Now, if you remember, we do have a formula that uses sine and cosine in it. It is our Pythagorean identity. We used it on the second question we did. So I'm going to use that here to help me find cosine. So sine negative 3 over 5. Make sure you put it in parentheses, going to square the negative 3 over 5. You should get a positive. So here squaring, that should be a plus sign. You should get positive 9 over 25. You could use a decimal if it's a nice decimal. If it's not, please do not use a decimal. Make it a fraction. Subtract it to the other side. So we get that cosine squared is equal to 16 over 25. Take the square root. So cosine, we get 4 over 5. But remember, we said cosine is negative. So we're going to put a negative with that cosine. So cosine is negative 4 over 5. So now to find tangent, we can divide sine by cosine. You can plug this right into your calculator to do it. I would put parentheses around those fractions so you don't make a mistake. And you should get 3/4 or 0.75. Now, if you want, make sure you remember, last step, double check your ASTC that everything came out okay. Now, they didn't specifically say which quadrant we are in, but similar to question 3 at the top of this page, sine is negative. Sine is positive in quadrants 1 and 2, so sine being negative means you're in either 3 or 4. Cosine is negative, so that eliminates quadrant 4, which means we have to be in quadrant 3 here, similar to what we did in the exercise 3 at the top. So our answer for tangent came out positive because we had the correct signs for sine and cosine when we divided. So that's good. If it came out negative because you forgot the negative with the cosine, then at this point you would be taking the negative off. If I'm in the third quadrant, tangent has to be positive, so you should get 3/4. I know this stuff is starting to get confusing, so please make sure that if you're stuck on anything you don't understand, email me, ask me a question on Google Classroom. I will respond. I'll make another video answering your specific question to try to help you out as much as possible. But we'll get through this together, so please ask questions if you're stuck.